Okay, so the spectral problems that I got assigned was group 9. So where I got the molecular formula with 10 carbon, 12 hydrogen, and 1 oxygen. So I put the molecular formula right here. And then for the degree of saturation, we have the formula back in the midterm 2. I think around those, but I couldn't remember what was specifically what time it was, but the formula was we have to convert it the number of carbons into hydrogen plus 2, and then minus the number of hydrogen that we have in the molecular formula. So, and then all of them divide all of them by 2. So we got the formula here, 2 times 10 carbons that we have here, and then plus 2. These are from the formula, and then minus the 12 hydrogen that we have divided by 2, and then we got the 5 degree. So that's our degree of unsaturation. After we found that, we first of all look at the IR spectrum. So in this part, since we have the degree of unsaturation, which is 5, so that means we're definitely gonna find 5 unique functional group. So I have downloaded and printed out this chart from the Brightspace, but which I know is definitely gonna won't be able to use it for the final. But I can just borrow it for at this moment for this tutor video. From this chart, we know that from the range 3,100 through 3,450, the top one is definitely going to be a chromatic ring, and then around 3,000 is sp3ch here, and then right below the 3,000, when we figure out there's a aldehyde group from this peak, so it's definitely an aldehyde from this chart. And then next we saw there's around 1,700 there's a carbonyl group here, so which is matched up this whole like shape of it. And then at the last, there's also a CC range around 1,400 through 1,550-ish, which I give the frequency ranges here, and then put with the respective function group from this chart. So that's the IR, and then secondly, we gonna move on to the carbon, the CNMR spectrum. So I'm gonna take out the summary of chemical shift region from chapter 13 worksheet. In this chart, it gives us the range that from 100 to 190-ish was like SP2, and then from 0 to 100, that's SP3. So I also put them here. And besides, I also print out this actually borrowed from the chapter 14 worksheet. There's a summary of chemical shifts for both CNMR and HNMR that I put each peak that respect to this specific functional group. I just wrote them down on each range. So for example, on 190 here, we got the aldehyde, and then from 120 through 160, so this 120 definitely going to be at the middle between 90 to 160. It's a chromatic ring here. And then from the rest of 0 through 40, we got a sp3. It could be a carbon CC or CH, but definitely a methyl group until we figure out the HMR spectrum in the second page. Oh, by the way, and I also put with the respect the functional group here with the specific range on the chemical shift. So we flip the page over. We got the HMR spectrum. Back in the first part that we discussed, that since we have 5 degrees of unsaturation, and we still from the CNMR, this chart, we know that here we got the aldehyde, this is a ring, and then this is a methyl. The reason why it is a methyl is because here we can see there are 2 peaks around here, but there's 6H, so that means it's definitely going to be split up, like one split up into 2 functional group, which like CH3 like that. So, and then for this part, for this 1H, I'm not sure how many peaks are there, but I just leave the 1H at here for this moment, and then if we continue to move on to the chemical shifts between 7 and 8, since we know there's a benzene ring, there should be like 6H, but there's only like 2H here, so it's definitely gonna be split up into 2 doublet, and it has to be symmetrical. So it could be like I draw it here as a symmetrical, or here, or like that. And then lastly, we move on to the top chemical shift around 10. We know there's like 1 peak here, and then also have 1H, so it's definitely there's no hydrogen around this carbon, so it's definitely going to be a singlet. And since we know this is an aldehyde, and then I put the aldehyde functional group, draw them down, and then make a connection with the benzenic ring. And then, so with that, we can definitely tell what would be the structure look like. So I just have to put all the informations in, and then it give me the graphs like that.